Right, thank you. I am Marinus, and during my 6 weeks as an intern at Dyalog this summer, I worked on an APL Python interface. So what is this, and why would you want to do this? Python is a highly popular scripting language. It has a few things in common with APL, namely that it's very dynamic and that it can be used interactively. Sadly, it doesn't have that much more in common with APL, which is why you'd want to do this. But Python is available on Linux, on Windows, on the Mac, on the Raspberry Pi, on Android as well, basically on every modern platform. It's used by hobbyists, by scientists, by businesses alike. It's basically, you can find it everywhere, and there are a lot of libraries available for it. So you can do cross-platform GUIs with it. You can do language processing, image processing. You've probably already seen some robotics, networking, social media. Just about everything you can think of, there's a Python extension for it. On top of that, Python is also used as an embedded scripting language in, for example, in Blender, which is a 3D modeling tool. So basically, if it can be done, it can be done with Python, and if it can be done with Python, you could also do it using APL. Funnily enough, there's even an add-on for Python that can do multi-dimensional arrays. I'm not going to, but as you see, this is for the people who don't know Python very well. Otherwise, it's a rather traditional language. So, what does Py'n'APL do? It allows APL. It allows Dyalog APL, the Dyalog APL interpreter, to start up and control a Python interpreter. And it also allows to do it in the opposite direction. So you can start a Dyalog APL from Python. It can exchange data. There are some conversions, and you can call functions written in one language from the other. So, because these are the conversions that are done automatically, you're going to see that when I demo it. But basically, Python's a bit more. Python is a bit more strict in its typing. Well, it's dynamically typed, but it makes some distinctions that APL doesn't. So basically, everything that's list-like becomes a vector in APL. Everything that's number-like becomes a number in APL. You'll see what a dictionary is and why it maps to a namespace. But it's a lot easier to show this to you than to talk about it. So let's do that. I assume this is, you can read this, right? So the first thing you do is instantiate this class, which starts up a Python interpreter in the background. And once that is done, we can evaluate Python expressions. So for example, 2 + 2, which gives 4. These can be parameterized, so we can express addition and pass the numbers in, and it will still say 4. And it does the automatic translation. For example, if we pass this, if we evaluate this list with a list in it and a string in it, it does what you'd expect. We get a vector with a vector and a character vector. All the way around as well. This, by the way, this wrapper is a function which gives the string representation. Well, if you pass a Python object into it and it supports it, then it gives the way you'd express it in Python. Python doesn't do is higher order arrays. You can extend it, and we do support it, but by default, it turns it into a list of lists. which makes some sense because if you use the NumPy library, which is the library that extends it like that, you can use it and it will turn it into an array. And APL can use this array as an actual array. And namespaces work like this. So that's a dictionary. It maps names to values. So that's basically what a namespace does. The other way around as well, of course. And finally, it's possible to call APL functions from Python code. So I've now defined a little callback function. So what's going on here? This one looks a bit complex. What's going on here is this takes one argument, this quad, which is going to become 4. It's going to multiply it by 8, by 2, giving 8, and it's going to pass it into this function here via Python. So if I run this, indeed it runs the function, this one, and you get 16 back, which is 2 times 2 times 4. Can also access Python objects by reference, so anything that isn't one of the things I mentioned, one of the simple types that I mentioned, can be passed more by reference. It's not quite by reference, but you can imagine that that's what it does, and it will act like that. So what I'm doing here is defining a little class on the Python side. It has one field, class X, it has one field Y, its value is 10 by default, and I'm instantiating it. So now, obviously, if I ask Python what is x.y, the syntax in Python and APL is the same in this case. It says 10, but what I can do now is grab this x and bring it into APL and access it from here, and it says 10. And I can change this, and then if we ask Python what it is, it says 20. So this can be used to access Python modules. So all those libraries that I talk about. One of those is NLTK. This one does language processing. So for example, if I do this, I now have this NLTK thing, which if I ask APL what it is, it will say, this is the Python module NLTK. And I can access fields in here. So this is its Python modules always, well, they're always supposed to include documentation like this. They don't always, but they're supposed to. This one does. But we can use it now in APL. So I can instantiate this class. This class, which I'm instantiating here, has a function in it which will take English words and give you the stem of it. So if I give it plurals, it will give the singular. So this is the class now. This is how you call a function. Well, APL is limited to monadic and dyadic functions. So Python's a bit more complex in that regard. Python has positional arguments, which can be anywhere from 0 to some large amount. And you can have named arguments. So what I've done is the positional arguments, you give them on the right. If there are named arguments, you can give them on the left. This one only takes positional arguments. So if I call this now, as you see, it's called the Python function, and it's done what it's supposed to, and it's given it back as an APL. Well, this is a vector of character vectors, as you'd expect. So let's retrieve some text to do some processing on. So what I have here now is a vector of those Python object references, which is a normal APL vector, which also means that I can access its its fields in this manner. So if I do this, it does the thing you'd expect. It applies this to all the values in here and gives all the texts of all the the first 20 tweets. You can get more if you ask it to, but the screen would fill up. Of course, you can use them together from APL. So I could take the 10th tweet and say what are the words in here, or what kind of partial speech do we have here. So we can now do without having to write APL code, or without having to write Python code, you can write this kind of code in APL. So I can say, what are the nouns here? Milestone, Dyalog 17. Well, there's apparently some kind of milestone. And you can do it the other way around as well. I have to do this one by hand because nobody ever wrote a demo for this. So it looks the same. So what it's done now is it started a Dyalog instance. It found it on the path. On Windows, it will find it in the registry. On the Mac, it will find it in your applications directory, so don't move it. And of course, this can now do the same kind of things. You could have a function, so Python functions that would be really awkward to write in Python, you can just write in APL. So you could say, if you want to count the unique numbers, this is key, and this will now work with as if it's a normal Python function. If you had a dyadic function, then you could give it 2 arguments. And if you have an ambivalent function, you can give it either 1 or 2 arguments. And if you give it any other amount of arguments, it will say error, of course. You can do it with operators as well. So this means you can apply APL operators to Python functions. Of course, then the function must be monadic or dyadic, otherwise it doesn't work. But if you have a Python function that can act like an APL function, you can use it like an APL function. And of course, the object-oriented stuff works too. So if I define a well, and this is how it handles errors. So no, it works.
It's called public key.
Yeah. Yeah, there is a colon.
It's missing from the left-hand side of the screen.
Yeah, could you move the screen over one?
Yes, but then the bottom disappears. Yes. Looks good now, right? More or less, yeah. So yeah, if you have any Python code, if you have any Python code and you want to interface with an APL application, that's possible too. So that was the demo. So finally, the requirements are Dyalog version 16. There's been some testing with 17, which doesn't quite work, but then again, version 17. You need Python version 2.7.9 or higher if you want to use Python 2. By default, it uses Python 3, then you need Python 3.4 or higher. The code is on GitHub, you can download it and play around with it. This is all still very experimental. So it doesn't, there are still bugs in it. There are still shortcomings. For example, it does not yet do multi-threading. If you try multi-threading, it doesn't do that. Yeah. So this is the work I've done. Are there any questions or?
Okay, so you implemented about 5 times more than we asked you to. What's next? I'm curious. What's missing from this interface?
Well, I could add threading in.
Threading.
Probably not that hard to do, but well, it would be a lot of work. But.
Would be good for robots.
So, what is the fundamental interface method between the Python? Is there an API on the Python side, like a C API for driving the interpreter, or do you have to do text processing to work between the sessions? I missed that.
It's serializing everything over JSON. That's why it's needs the. Of course, if you're using those references, then it just sends a reference over, which is a number.
So you're essentially running an eval on a JSON on the Python side to the REPL, or is there a different interface for it?
Well, if you run, everything, say all of this stuff just becomes those eval statements in the low level, and what that does is basically it has 2 sockets open, and it starts a Python interpreter, and it opens a socket, and the Python interpreter listens on it, and the APL thing will send it a message which says, go evaluate this, and then Python will send the message back with either error or...
Over like a TCP socket, so you've got like an interpreter on the Python side that's taking in instructions over a TCP socket and then sending output?
On Unix, it uses using Unix sockets.
Okay.
On Windows, it uses TCP.
Okay. So does Python provide a lot of features for managing individual sandboxed environments, or when you work on this code, are you populating the actual parts of the environment that are driving the socket stuff? Like, so how much encapsulation is there? Do you know what I mean? So like, could you evaluate code in this side that would reveal how you're implementing the socket driver and things like that? Could you get access to
well, you know, Python is pretty self-referential if you want it to be, so is APL. So if you go digging, you can find it. Then again, if you want to break it, you can just say XX stop or...
Okay, thanks.
By the way, there are much simpler ways to break things. Python and APL are running on the same box on this. Is there any reason that they couldn't run on two separate boxes since you're going across TCP/IP?
One of the things I didn't show you is that it does do interrupting. So if it's probably easier. Well, it's not so easy to show here. But if you're willing to, so say if you're running Python code and it's taking a long time and you press interrupt here, then it uses it will use the operating system methods to actually send an interrupt to the other process, and that wouldn't work if you did it on another machine. But if you're willing to live without that, then it could, in theory at least.
Okay, thanks.
Don't think it would be very fast.
Okay, thank you, Marinus. That was excellent.